Hello my friends. In today's video I'm gonna show you let's say one more method of solving the exponential equations. I don't know what is the proper name of this method, but let's call it like mixed basis, or if you want to fraction basis, because as you will see we will come to really like bases that are fractions, and at the very beginning you will see that these are like mixed bases. So to understand this like more precisely, let's have a look on this example. Let's have the exponential equation 5 to the power of 2x plus 1 plus 6 to the power 2x plus 1 is equal to 11 times 30 to the power of x. Why is it called like mixed bases? Now, as you can see, the first base of our exponential is 5, and the second base, or the base of our second exponential, is number 6. And as you can probably see, number 30 is 5 times 6. And this is the fact we are gonna use at the very beginning of solving this exponential equation. And then there will come like one more tricky thing when from this equation you will see that we will have bases of like fractions. So that's why I think we can call this method like mixed basis or fraction basis. So let's see what we can do here. The first thing we can do is to use our formula from here, but the other way around, which means 5 to the power of 2x plus 1 will become 5 to the power of 2x times 5 plus 6 to the power of 2x times 6 is equal to 11 times, and 30 to the power of x, let me do it here, can be written like 5 times 6 to the power of x. And basically we don't have the formula here, but the formula says that a to the power of, let's say, r times a to the power, different bases, times b to the power of r, but the same exponents or indices, is equal to a times b to the power of r. Okay. And in this example, or in this procedure, we are using it like other way around. So 30 to the power of x can be written like this, and then we can write by using this formula or fact that this is 5 times 5 to the power of x times 6 to the power of x. And now you can see that we really have two bases, 5, 6, in all the exponentials. And what can we do now is we can simply divide both sides of the equation by this factor, which basically means that we will multiply both sides of the equation times 1 over 5 to the power of x times 1 over 6 to the power of x. I wrote it this way so that you can see easier way how and why is it done so. So let me put the 5 like constant or coefficient first. Then it's gonna be 5 times 5 to the power of 2x over 5 to the power of x times 6 to the power of x plus, again I will put the 6 as the coefficient, the first 6 times 6 to the power of 2x over, and let me change the order of this multiplication, because we know so far that it doesn't matter on which order do we do, because 5 times 6 is the same as 6 times 5, and this comes from the geometry, because it is like calculating the area of rectangle which has sides A and B, and it is calculated like A times B, but it can be also calculated B times A, because then it would be a rectangle with such dimensions, but still the same area. We just rotated the rectangle 90 degrees. That's why that's how you can understand that it doesn't matter if you multiply A times B or B times A. Okay, this was like a little explanation, and it is equal to 11, because if you multiply the right side of the equation by this fraction, then the numerator and denominator cancel each other. Now, as you can see here, the numerator here is equal 5 to the power of x times 5 to the power of x, which would mean that one of the 5's to the power of x from the numerator will be cancelled by the numerator 5 over x, okay? And the same thing applies in our second fraction. This can be written like 6 to the power of x times 6 to the power of x, again because of this formula, okay? And then of course this will cancel, 5 over x will cancel 5 over x from the denominator. Let me do it like this is the explanation, but now what I think is a good idea, and I want to have it like and explain the way which I find is the easiest and maybe the common thing. It would mean that if we had the equation like this, you simply realize the fact I mentioned here, and you just cancel these two, and from the denominator the corresponding factor. So if you have a look at this equation, then it will be, let me put it, let me write it like this. So it's going to be 5 times 5 over x, 5 to the power of x over 6 to the power of x plus 6 times 6 to the power of x over 5 to the power of x is equal 11. As you can see now, and that's why I really called the method also fraction based, though it's fraction basis, though it doesn't matter, because the base can be any number. So the question is if fraction basis method is good, but it doesn't matter. So we can simply write now our equation like 5 over 6 to the power of x plus 6 times 6 over 5 to the power of x is equal to 11. Now if you have a look at this, these two bases are almost more or less the same, and to simplify or get something we know how to solve, we will change this exponential by using this rule, or if you want to, by using this rule, which means that our second term in the equation will become, maybe you know already the answer, so I'll let you think about it. Yes, to the negative to the power of negative x is equal 11. Okay, now if we have the same basis, we can simply see, maybe you can't, so I'll explain for some of you that this can be really written like something like this. 5 over x to the power of x is equal to 11. If you could see it directly here, then because this term, or this part of the second term can be transferred to the denominator with the positive exponent of x, and now probably you can already see that there comes the substitution, which says that 5 over 6 to the power of x can be our new unknown. In this case, let's call it u again. So you can probably see now that after this substitution we will get the equation which is gonna be like this. And now to solve this equation, you simply multiply both sides by u, and it's gonna be well-known quadratic equation, which you can solve very easily by using any method you prefer. For example, factorization or discriminant or quadratic formula if you want to. So 5 times u squared minus 11u plus 6 is equal to 0. Let me just speed up the process here, and you just use whatever method you want. You will come to the results that u is equal to 1 or u is equal to 6 over 5, okay? Which means we have the solution of our quadratic equation after the substitution, and based on the information from the previous video, you can very easily now solve the equation, because you know that 5 over 6 to the power of x must be equal to 1. Now the question is, where is hidden 5 over 6 in this, so that we can see any exponential behind. And this is quite easy, because 1 is the same as 5 over 6 to the power of 0, because any number to the power of 0 is equal to 1, which means x must be equal to 0. So this is our first solution of the given exponential equation, which is this one. Okay, and we are not done, because we have two results for u, and the second result says that 5 over 6 to the power of x must be equal to 6 over 5, but we already know, again by using the same fact as we used here, okay, you can see this is more or less the same, not more or less, this is the same thing, and 6 over 5 can be written as 5 over 6 to the power of negative 1, which means then that x is equal to negative 1. Okay, so this is our solution. Now I'm not sure if I want to do this, but let's do it. Like kind of exercise, and let's do the check if our calculation is really correct. Let me take this equation and let me put it somewhere here so that I can see the equation, and I didn't copy it, okay, so that I can see the equation and also the results. So let's have a look. The left side for x being 0 is equal to 5 to the power of 1, because 2 times 0 is 0, plus 6 to the power of 1, which is 5 plus 6, which is 11, okay? And the right side for x being 0 is equal to 11 times 30 to the power of 0, 30 to the power of 0 is 1, so 11, which means the first root is correct. Let's do the check for left side, x being -1. It would mean that this is gonna be 5 to the -2 plus 1 plus 6 to the power of -2 plus 1, which is 5 to the power of -1 plus 6 to the power of -1, which is 1 over 5 plus 1 over 6. The common denominator is 30, and this is gonna be 6 plus 5, so it is 11 over 30. This is my left side value for x being -1. What is the value for right side? It would mean that right side is 11 times 30 to the negative power of 1, which is, okay, I can see the result is correct, 11 over 30. So the left side is equal to the right side for both, and that means that our set of the roots is 2 elements set, and there are numbers -1 and 0. So this is the solution of our, let's say, very hard and quite hard exponential equation. Okay. Now, concerning this, I have one more example, and I'm gonna show you that even if the equation looks like mixed. Looks like the solution can be found by the method mixed basis. Sometimes when you really start solving the equation, you will come to the equation which solution is really easier than you were expecting. Okay, so let me show you another example. But first I need to get rid of this. So let me delete the lines I'm not gonna use anymore. So my equation now would be, and if you will have a look at this equation, you can be really scared, but there is nothing to be afraid of. Yeah, you can see that our exponents are, or indices are fractions, and not like simple fractions, but fractions with the unknown in the denominator. And also, as you can see, you can find, or you can see that there is also decimal number. So at the first look, this equation doesn't look very easy, but as I said, a lot of times in mathematics you simply start solving, and during the procedure you will find that this equation is not that hard as you were expecting at the very beginning. So what can we do now here? And I didn't mention during previous videos because it's not like always, but it is a good manner a lot of times to not use the bases as composite numbers, but to use the bases as prime numbers. And in this case, if you think about the bases, number 10, 25, and in this case 50, you can see that all of these bases are like multiples of number 2 and number 5. So you simply start playing around with these multiples, and you start try to find out what the solution could be. So number 10 is 2 times 5 to the power of 2 over x, plus 25 is 5 squared to the power of 1 over x is equal. We don't touch right now the decimal number. You will see that there is no reason for this. Quite often there is no reason for this in this kind of equations. And 50 can be written like 5 as we want to use the primes, 5 squared times 2 to the power of 1 over x, because 5 squared is 25 times 2 is 50, so we are fine now. Probably you can see what this equation is leading to, but let's go step by step. So this is gonna be like 2 to the power of 2 over x times 5 to the power of 2 over x plus, and you can see that this is gonna be 5 to the power of 2 over x is equal to 5.25 times 5 to the power of 2 over x times 2 to the power of 1 over x. Now, if you think about this, there can't be used the division or anything else, but what you can maybe see right here, right now, you can get rid of these numbers or these terms or expressions, and this is really good news. Then there remains only 2 to the power of 2 over x and 2 to the power of 1 over x, which is quite okay, because you probably can see also the substitution behind it. But let me explain a little bit in more details. So basically, how can you simplify this expression? You can see that we have common factor in these two expressions or these two terms, which basically means that you can take this common factor in front of the parentheses, and then there will remain like 2 to the power of 2 over x plus 1 is equal 4.25 times plus 2 over x times times 2 to the power 1 over x. And now probably, and I'm pretty sure you can see already, that you can cancel these expressions, because if you would do the operation like this, then it's quite clear that they will cancel each other. So what will remain is really something which is quite easy to solve, because now you already know the procedure how to solve this one, I guess, or yes, you can, but you cannot maybe, because I made the mistake, because it should be something like this, otherwise it would be a little bit more complicated. So now, what would be the next step? Yes, the next step would be the substitution. U is equal to the power 1 over x, and what will happen? It's gonna be u squared plus 1 is equal 4.25 times u, and as you can see, in all the examples I was showing or making the videos about led to the quadratic equation u, as we solve the substitution, it's good to show in the same color. So it's gonna be u squared, take away to 4.25 u plus 1 is equal to 0. Okay, to solve this equation, you simply use the quadratic formula method, and before you calculate u1 and u2, it's a good manner to calculate the discriminant, because based on the value of discriminant you can say if the equation has 0, 1 or 2 solutions. If you would solve it, you can simply use the calculator, because not nice numbers will occur there, but at the very end, if you do your calculation, which I'm not gonna do right now, you will come to the result that u1 is equal to 4 and u2 is equal to 1 over 4. And when you connect this information again with the substitution, it would mean that 4 is equal 2 to the power of 1 over x, and this is if and only if, because 4 is 2 squared is equal to the power of 2 squared is equal to 2 to the power 1 over x, and this is if and only if 2 is equal 1 over x, which means times x, 2x is equal to 1, so times 1 over 2, x is equal 1 over 2. This is our first solution, and the second solution is again from the second root of our quadratic equation, and it is, and also back again to the substitution, 1 over 4 is equal to the power 1 over x. This is equal 4 to the power of negative 1. Parentheses are not needed, but doesn't matter now. And it would mean, and this is also again can be simplified like 2 to the power of negative 2. Okay, which means connecting these two information in one means that negative 2 is equal to 1 over x, because bases are the same, and as this equation must be true, then also the exponents or indices must be the same, so they must equal. So again, times x, negative 2x is equal 1 times times negative 1 over 2 means x is equal negative 1 over 2. If you would do the check, you will find out that these two solutions are okay, and it means the set of our roots is two-element set, negative 1 over 2 and 1 over 2. Okay, so that's all about the last and, let's say, the most complex exponential equations to solve. Okie dokie. Thanks for watching. Bye bye.